Hello. So we're given a problem um, that is an area one. In a sense it's a parabola, but I'll get to that in a second. So we're given that a piece of string is 35 inches long and that it is cut with one segment used to form a circle and the other a square. What is the circle perimeter? So that's what we're asked. If the combined area is minimized. So we're trying to minimize the area. So this right here, the 35 inches, I'll write it down here. 35 is equal to the circle circumference, which we'll put as C, circle circumference, so I guess that'll just be short for circumference, plus the perimeter of the square, just like that. Alright, so, and of course down here you could write C is equal to 2 pi r, and then P is equal to 4 times the side length of the square. And knowing this, we could isolate it. So, a piece of string, yep. So, what we can do now, we could isolate, since we're solving for the circle perimeter, we're going to want to isolate what P is, right? We're going to put P in terms of C. So we're going to subtract C from both sides. So we would end up with P being 35 minus C. Okay? Now, looking at these equations over here, these are really important in a second. That's for figuring out the sides, right? These right here are the sides. Um, so then we're going to have to use the formula for a square. The area of a square is just simply, it's going to be side squared. And then for a circle, area of a circle, I'm just going to draw C. You know what that stands for. Maybe circ. I'm going to go with circ. Is equal to pi r squared. Okay, so in this situation, well, we're looking at this formula, right? Well, this is part of the equation. We're having to minimize the area, so we already have the equation for basically the perimeter, right, of each. We have them in terms of p now. let's go on to the area now, right? So these two areas have to be minimized, right? Uh, so it's going to be, let me think about this. So we're going to have just area. The combined area is the area of the circle, which we'll have as AC, area of the circle, plus area of the square. Oh no, not P, it's area of the square. And I'm going to have C for total, right? Now we can figure out what this will be by using these formulas over here, right? And using this equation up here. So the area of the circle is going to be 2 pi r squared, right? Pi, but of course r, as we can see right here, is going to be c, which is the variable we're going to be using, divided by 2 pi. That right there is r. Now we're going to have to square it, and then we already multiplied by pi. So that's what the area of the circle will be. Now we're going to add the area of the square, which is, we're going to have to use this equation up here, right? So normally we just have p over 4, which is this equation down here, right? To isolate for s, we'd have to just do p over 4. But we know what p is in terms of c. So we're going to replace p with this up here, this equation. And we're going to divide it by 4 because we're isolating for s. And then we're going to square it. Now, for this problem, yeah, that's over 4. It looks kind of bad. Let me get my calculator. I forgot to load it up here. Sorry about that. We'll need it for this problem. There we go. All right. So, using our calculators, like I said, it's actually a parabola. And you could shorten this a little bit. You could make it a little bit easier for you. Like the pi's would actually cancel and you'd still have pi in the denominator, but we're just going to type it in as we see it. So pi in parentheses, we're going to have x, just because that's the only way the calculator will accept it, over 2 pi. And we're going to square it, and we're going to add 35 minus x over 4. And of course the bounds here that we're going to need, which are kind of important but not really, the x has to be between 0 and 35, right? I'll have to zoom out here. I could do window. Yeah, it's taking a second. It's a slower calculator since it's a digital one. It's emulated, so it's a little bit strange. Okay, if it'll load here, hopefully it wouldn't take too much longer. All right, well, looks like it's kind of, okay, there we go, finally loaded. Let's zoom out. All right, as you can tell after zooming out a lot, we have a parabola, which is what we were wanting, right? Now we're asked for the minimal area, which you can see right there. So calculate the minimum. We have to be on the left bound, which we are, and then we have to go to the right bound, right there. Oh shoot, I did not mean to do that. I'm gonna go like 99, I guess. Yeah, that's in the bound, and then enter. Okay, come on. There it goes. So if we're correct, the answer should be 15.4. That should be the circle perimeter, which is correct. So that is it's kind of an interesting problem, but that's how you'll do it.